Hello everyone, welcome to What Show. Today's show will be the introduction of China coding. Of course, if you just want to know coding techniques without rigorous basic mathematical concepts, you can jump this video. So why do we need coding? In the past, we talked face-to-face where the sound communication can simply work. While now we talk to remote individuals, where the digital telecommunication system is used. In this system, coding is a technique to guarantee the correctness of information transmission. In the digital telecommunication system, we have original binary information in the beginning. That information is coded through the channel coder as a binary code word. The code word is modulated into array COM symbols that are passed through the channel with additive noise to the receiver. The receiver demodulates the signal and decodes it into received binary information. Noise always exists. Noise is unwanted waves that tend to disturb the transmission and the processing of message signal in a communication system, no matter internal or external. Let's look at two pictures on the right. The top shows thermal noise that glitchy signals in every direction. The bottom shows the phase noise that glitchy signals in two directions around. We quantify the noise effect by SNR, which is the ratio of the average signal power to the average noise power. Below is the equation. Please note that we can write in a way of power or way of energy, where PS is the average signal power, P0 is the average noise power, W is the signal bandwidth, T equals to 1 over W is the time slot to count the average, ES is the signal energy during the time slot, and N0 is the noise power spectrum density. There are two kinds of channel. The first is wire guide channel. That is usually time invariant and bandwidth limited. For example, traditional cables including telephone lines, coax cables, optical fiber. Another example is the waveguide. The second type is wireless channel. That is, on the contrary, time invariant and power limited. The first example is the broadcast channels that usually line of sight and linear, like wireless radio. But the cellular network is a multipath channel instead of line of sight. Another example is the nonlinear satellite channel that covers a large area in a low SNR. If the demodulation uses hard decision, we can combine the modulation, channel, and demodulation into a digital channel model. We usually use binary symmetric channel as a standard model. Here, P is the probability that an error happens on one bit. So what is the upper bound of transmission rate? Channel has given the answer. In an AWGN channel, the channel capacity in bit per second is channel bandwidth multiplies log 2 1 plus SNR. Also, the channel capacity divided by the channel bandwidth is called the spectrum efficiency. Before moving to actual coding scheme, let's introduce several basic concepts of coding. In this series, we talk about channel coding, aka forward error control coding, or just FEC. We use K to denote the message bit length, while N to denote the code word bit length. K divided by N is called the code rate, that is less than 1, because we need to add extra information into code word, aka N is bigger than K. There are two types of codes, the block code and the convolutional code. The convolutional code is special because it uses memory to include m previous bits. We will talk about these two codes in the future. Now let's look at the other two basic concepts, binary field and vector space. What is a field? A field is a set of elements in which we can perform addition, subtraction, division, and multiplication without leaving the set. Binary field denoted by GF2 is the set 0, 1 together with modulo 2 addition, multiplication, subtraction, and division. The modulo 2 operation is given on the right figure. You can see that addition and subtraction can be realized by an OR gate. Multiplication and division can be done in an AND gate. Although the division requires an extra input check for special cases, you know we cannot divide 0. Now let's move to the next. Before moving to the vector space, we need to know what a vector is. A length-n binary vector is a length-n ordered sequence with components selected from GF2. An example of 8 length 3 vectors is given in this slide. The length-n vector space includes a length-n vector set, addition, and scalar multiplication. Please note that the result from these two mathematical operations is also inside the length-n vector set. The mathematical operations are given in this slide. Also, we can combine several vectors together with several coefficients. The result is still in the vector space. For any subset in a vector space, we need to fulfill two conditions. The all-zero vector is in the subset, and the sum of two vectors in the subset is still in the subset. Thank you for watching. This is the end of this video. If you like this video, please press like and subscribe. See you next time.